Okay, good. Well, hello. Welcome to the season finale of Astronomy on Tap Jena. I am Eleni Vardoulaki, and today with us we have Hongming Tang and Micah Bowles. They will tell us very fascinating things about artificial intelligence, science, astrophysics, citizen science. And as I'm talking to you, there is a big thunderstorm outside. So maybe things will stop. We will see, we will see. So hello, Hongming and Micah. Very, very nice to have you with us today. And thank you very much for agreeing to do a joint event, because I'm very excited about this. Whenever there are two people on the event, I can play all the games. So I'm very excited. Right, so guys at home, please let us know where you're from. And hello to everyone around the globe. Thank you for joining. If you have questions, let us know. And of course, subscribe and follow on all the social media, right? Facebook, Twitter, Instagram, what else do I have? TikTok, YouTube, everything there's out there. You can follow Astronomy on Tap Jena. Okay, good. Right, so now let's start. We get to know our guests for today. So I will start by asking Hongming and Micah. Let's start with Hongming. Tell us a bit where you're from and what inspired you to study astrophysics.
Okay, so hey, yeah, hi everybody. I'm Hongming. I'm basically from China, so my inspiration on astronomy was quite simple, to be fair. I was always stargazing when I was in middle school. So the 3 years of living in a place that far from my home, not that far, but you know, we have to live in the school. And my time after 8 p.m., 9 p.m. Every day was gazing at the stars, right? So that's what inspired me. And start this path. Yeah.
That's beautiful. And how about you, Micah?
My path is a lot less beautiful as such. Yeah, so I think for me, it sort of is just nice in between of trying to understand as much as I can. I really like learning and I like understanding how things work. And I like the scales of things. So I like just how big everything is and how that sort of lines up with how we perceive the world, right? We can see stars, but understanding how big they really are and how big things are in the universe as a whole was very exciting to me. So that's why I leaned more towards astronomy than particle physics or something where you're thinking about tiny things that are impossible to think about, essentially.
But also the scales of the universe are huge, right? It's sometimes very hard to comprehend how big things are, right?
Yeah. When people ask me how far away things are, I just say, yes, very far.
Yeah, okay. I will also do that. Why not? Not trying to explain with human terms, because it's very difficult, right? To comprehend all this. Amazing. You know, I'm somewhat in between, I think, the two of you. I was also a bit on the romantic side when I was a kid, but then I changed my mind. I wanted to be a lawyer when I was a teenager. And then again, I changed my mind. And I wanted to be a physicist because I saw a very nice movie with Keanu Reeves, Chain Reaction. And they were featuring an astrophysicist, a woman astrophysicist in this movie, and it was action and it was awesome. And I was like, oh my God, scientists have so much fun. We have a lot of fun, guys. We have a lot of fun. Right?
Yeah, a lot of fun.
Right.
Yes, a lot of fun. That's why I want to ask you next a bit about your career and you know, your current position and research. So tell us a bit. Let's start with Hongming. Tell us a bit about what happened after school. You know, how did you end up getting into the current position you are now?
Yeah. So if I said 3 keywords about my stuff, I would say radio galaxy. It's my scientific topic. I would say machine learning is a big family of technical tools I'm using. And the three is citizen science. So I'm always heavily involved in citizen science. So in few sentences that I'm working on applying machine learning algorithms or methods on radio galaxy detection and classification stuff with the help of citizen scientists. So that's a summary of my research. About my current position is I wouldn't say it's a miracle, but it's more or less an accident. Yeah, it really is. I was trying to apply for a postdoctoral position around the world, and the director of my current institute was in Manchester. So he was a professor in JBCA, the place I graduated from. And I really have no idea about his students. I didn't know at all. So one day I gave a lecture on my research, and one of the audience was actually his student. So I mentioned that I'm hunting jobs on the lecture, and he wrote a really long email to the director. And the director and my current mentor give me the job. That's it.
Wow. Wow. You must have been really good in that lecture. Congratulations. Awesome.
Thank you.
Awesome.
Thank you. Yeah. So it was a really unforgettable experience.
Amazing.
Yeah.
Amazing. Good. And how about you, Micah? Tell us a bit about your career path and what you do now.
Yeah, it's a great question. I don't really know what I do now, but if I had to choose.
Now we are talking. Okay. Now.
Yeah. So I did my undergrad, my bachelor's in Germany, in Cologne, and the best part of that was the research project at the end. And I spent way too long on it because I wanted it to be good, which paid off, but it was a sort of the best part of that experience. And so I moved to the UK to be with my partner, and decided I wanted to keep learning. Didn't want to work, it was boring. So I applied to the University of Manchester, which is where we lived. And I wrote 2 professors who I found out afterwards are partners of one another. And but I liked both of their research, and I ended up with a very good supervisor who then offered me a PhD project in very similar things. So my research covers probably AI a little bit, and radio imaging, as well as classification. So the actual process from getting the data to the telescope all the way into an actual picture, that's a whole thing in and of itself. And I do a lot of that as well.
Very fascinating. And we'll talk a lot about artificial intelligence today, and galaxy classification and citizen science, because that was our topic for today. And it's the topic also for the quiz that is, you can find it on our social media. You should play. It's a very nice quiz. Designed by Paul Hombach from Bonn. So he's a collaborator of mine. We do the quiz together, and me, of course. So go to our social media, follow us, and play the quiz. So that's a very, I really like to learn how people go to do what they do and what they love, and how fascinated they are about the career. Thank you for sharing this with us. But now, we have a little icebreaker before we start talking about science. Okay, we need to learn a few keywords better. We'll play a game. We'll play taboo. Okay, so this is how it goes. I will give a word to Micah, and he cannot say this word. He has to describe this word to Hongming. Okay, right. And also we'll give him a set of 4 words that he cannot say while describing this word. And he can also use this word. Okay, so 5 words in total. Or, or if it's I also have an example with 2 words. So it's a bit difficult, but you can do it. I'm very confident. And then we will play 2 rounds. Then I will give one to Hongming. Okay, so let's do this properly. First, I will share with you, Micah. Oh, I'm so excited. Okay. Let's see. So excited. I haven't
You're
played
excited
again.
because you don't have to do it.
Yes. Okay. I see. So I had to do it live without any warning. I tell you, I was invited to the festival, and actually it was amazing. It was a bit north of Vienna in Halle Saale, and they paired me with another scientist, and we had to guess each other's occupation from this game. Okay. Yes, that was really tough. Yeah, I got it wrong. I got wrong all of them, really. Okay, so your words are the ones in the, and then you cannot say all of them. And you have 1 minute. Okay.
I have 1 minute. Oh, this is timed.
Yeah, I'm timing you because, you know, TikTok,
Okay.
TikTok.
It is, it is a catch-all phrase for statistical methods. Just checking the list that I can say that. And there's debate as to whether or not this word should be used or if it's too vague in the fields.
Oh, I didn't know that.
It's primarily computer science, Hongming. We're thinking computer science. We're not thinking astronomy, just to clarify that.
2 words. Let's help a bit.
It is 2 words.
Yeah.
And it's about teaching computers stuff.
Machine learning.
The more general phrase of that.
Artificial intelligence.
Yes, very nice. Well done. I didn't know there is a debate about using the term. We will get
There was.
Okay. I want to learn all about it. Okay, because we have also some true or false later. You will help me with that. Excellent. Okay, very well done. Let's go to the second one. Okay. Let me not make a mistake here. Right. So you have 1 word to describe, and you cannot say the 4 underneath, or you know that word. Yeah.
Okay. Right. So
I believe in you.
Okay, so this is something you're really familiar with. Okay. You're really familiar with in your research. It's 1 word. So back in the time that we study galaxy physics, this is a diagram you always see by Hubble. So the diagram is used to do this identification stuff. So what it identifies?
Flowchart?
Yeah, sort of. So 1 word. What it is trying to identify about the galaxy.
A pipeline. It's a pipeline of some kind, right?
Hubble. So a diagram.
The Hubble sequence?
Yeah, sort of 1 word.
1 word, Hubble sequence, but 1 word. I should know this, shouldn't
I? So diagram, invented by Hubble. He used this to describe galaxies, right?
Optical galaxies, just to clarify that.
Yeah, optical one.
You're not allowed to say that, but.
It's 1 word you're extremely familiar with.
Evolution, galaxy evolution.
Close.
I'm not sure I'm that familiar with this.
Remember the fork, do you? The fork
It forks
of
into, like,
galaxy.
spiral and elliptical galaxies,
Yeah,
right?
close. Yeah. So
Uh-oh. Please don't give me
close.
my PhD at the end of this. If my supervisor's watching.
Come on, you have it. We do this every day, but it's a general term. I'm helping. It's a
Oh,
general.
it's not specific about Hubble.
No,
No. I'm just
It's
giving
general.
an example.
So it's classification,
Uh,
binary classification,
of what? Classification? What? No.
galaxy classification, radio galaxy classification, jet classification, morphological classification, morphology.
Yes, very nice. Very nice. Okay. It was it was
I
difficult
like
because
the hand waving.
it was a very difficult one. I was very cheeky here. I'm sorry. He couldn't say shape, structure, or classify. So it's like, yeah, but very nice with the Hubble one. Yes, very good, very good. Okay. Now is your chance, Micah. One more round, because I'm having too much fun.
I have to redeem myself.
Okay, this also is hard. It's very hard.
We live in the arm of this structure.
Milky Way?
A general term for what that is.
Galaxy.
I feel like that was very good.
Wow. You see, if you know a few things about where we live, it helps.
Yeah.
Very good. So guys at home, if you ever play this kind of taboo with astronomy questions, now you know how to, describe. Okay, so last one. Okay, last one. So that's that is difficult. I'm sorry. I gave you the most difficult ones. I'm sorry.
That's okay. It makes me look really good, Elodie. Thank you. Or really bad.
Okay. So it's sort of the thing we both have developed. It's a computer science terminology.
Deep learning.
One word. It's usually written in our papers after machine learning. So machine learning, what we developed, things like that.
I usually write the word for afterward, so I don't think that's it.
You got it.
Machine learning for astronomy.
You're good. Okay.
Supervised.
But after, not supervised is before.
Classification.
Close. Say you may use it to replace. Okay. So classifier belongs to that word.
Classifier belongs to that word.
So what can I say that? No. Right. What can I do about that? So right.
Is it about trying to explain something?
You can use the word computer. I don't have the word computer here.
Yeah, it's computer.
Oh, computer vision. That's not one word. No.
That's not one word. So it's a big family of computing scripts. No, that's not a good explanation.
I'm about to go down a rabbit hole that I don't think people will enjoy.
Oh my god. So it's both computer science and mathematics. Okay.
Statistics.
And we use it all the time. You and I, we use it all the time.
Differentiation. Variant
Well, it's
calculus?
broader terminology. We write it all the time.
Write it.
Yeah. Um, yeah. Oh God, I give up.
This is hard.
This is like it's so common, but I really don't know how to explain it somehow.
It's like when you try to ask for people for the simplest words, and then it's very difficult to do that. Yes.
Yeah.
But he said one word that was key, and you can convert it to what this is: script.
Yeah.
Code?
So how else can we say a script if we run?
What
is it?
Yeah.
Code or pipeline or coding
or
software
or
software. How many words are there for?
There are a lot. Okay. I'm finishing this. Time's up. So the word was algorithm.
Oh.
And it's such a simple, beautiful word.
It is more general.
A very Greek, beautiful word that created a lot of chaos. So just now, like most Greek things do. Yes. So yes, the word was algorithm, and it was very hard to describe. And Hongming did very well, but it was hard because we don't. I mean, you have to go.
Apologize.
Don't apologize. It's a game. You couldn't say code, program, language, and artificial. So, pretty much, yeah, it was very hard to explain it. So I hope you enjoyed the game. And probably you will never play a game with me again. That was the last one ever. Or never accept an invitation for a live from me ever again. Anyway, I hope I didn't traumatize you too much. But anyway, so all these keywords are setting a bit the scene for our next discussion, because it's all about that, right? So they are simple words, but very difficult to explain. And it's pretty much our everyday life. We're seeing very nice, simple things in the sky, and we have troubles explaining them, right? Or maybe a bit more complicated things in the sky. So I'll go back to my set of questions. Oh, look at that. The sun came out. It's a beautiful day. Okay, so we talked about machine learning and artificial intelligence, but why is it so important for us scientists? Why do we use it in science?
Hongming, do you wanna start?
Oh, I should be the one to do it, right? So for me, I'm not expert on AI. If you consider the deep mind people, right? They are the experts, but not me. I'm basically a AI practitioner as a astronomer in the field. So for our research, say, artificial intelligence, or in a narrower regime, machine learning, I would call it data-driven intelligence. We hope these big family of algorithms or technical tools, they could mimic some intelligent behaviors of human. Say we want it to reason the answer behind a question. We want to trying to figure out a relationship of different scientific metrics, the properties of astrophysical object, and we wanted to detect outliers that we never recognize. And all of these questions, or all of these things, are why we wanted to use artificial intelligence, in my sense. And to be honest, I'm fancied by AI, because there are always many stuff I have never heard of that could perhaps pave us the way to new science. Yeah, that's for me the reason.
And how about you, Micah?
Yeah, I think as with everything today, Hongming and I are looking at things from different perspectives, which is great. So yeah, I think that for me, there's two main things, and that is how fast AI is once it's built, and how difficult it would be to do what it does without the algorithms that are available. So I think me and my colleagues the other day, we were chatting about it, and we figured that if you gave, you know, a PhD student infinite amounts of coffee and enough training time and a really good sort of window to look through galaxies, you could have them classify sort of 120 galaxies per minute. That was our like maximum number of like really fast level. And you can't really sustain that, but it is, you know, at peak performance, that's theoretically possible. And a colleague of mine ran through his machine learning algorithm on some data he had, and he classified 10,000 galaxies per minute. So the scales are quite different, and I think that's really impressive. And with the new instruments that we expect in astronomy as a whole, doing bigger and better science, you just can't afford to hire enough PhD students and supply them with infinite coffee to sort of get them to do that. So I think that's for me one big thing. The other thing is how easy it is to build in comparison. So it is data driven, and I think that's sort of how I would phrase it. If you're not familiar with the ideas, you can think of it as data driven modeling. So in normal statistics, you sort of decide on things that you think you understand and tell a computer about those things, and then pass through data and see what it does. In machine learning techniques, generally you show it all the data, or as much data as you can, and then ask it to look at new data and try to repeat sort of what it's learned. And for really complex problems, it's really hard to do the first one. How do you tell a computer to look at a picture? Like, that's so difficult. It's been a problem in computer science for 40 years. Computer vision is a whole field, and it's very difficult. And for that specifically, for these really high dimensional, high issue problems, machine learning really shines. So that's why I want to use it for science.
Mm-hmm. So it's the large amount of data that humans cannot possibly classify. And also we want to make our lives a bit easier, so we have time to do the science instead of looking at the, I mean, beautiful, but yet a lot of images all day, right? Yes. Yeah. Okay, we're talking about artificial intelligence. What really is it? Because I think there is you already mentioned a few things, but I think there's a bit in the general public, they hear the word artificial intelligence is now everywhere. It's when we travel, it's in our choices, when we want to watch a movie or want to buy something online, and in science, we also use it now a lot. We have the words machine learning, we have the words big learning, and I bet more words that I don't know. So, excuse me. So my question is, yes, in general, what is it, and the advantages, limitations, and a future view, let's say regarding our science, right? Because this is what we are, scientists. Maybe Micah, you want to start first this time?
Yeah, sure. Yeah, what is it? That's a good question. I think, so like I said sort of earlier, the word artificial intelligence is very vague. And I think that's sort of the contention that I was talking about, is because it's so vague, it means a lot of different things, right? And there are a number of words that are sort of becoming more normal, at least in AI fields, that describe different ideas within pop culture as a whole. So AGI and singularity, artificial general intelligence, and the singularity, those are two concepts that sort of people are most probably relate to AI as a whole, where an AI model can do what a human can. That's artificial general intelligence. And then the singularity is when an AI becomes so powerful that it, sort of Skynet sort of thing becomes so powerful that it dominates the world and makes humans obsolete. Those are really, yeah, those are not things that are very close at all. The closest that anyone has come, I think, is this year, DeepMind published a model called Gato. Look it up, GATO.
Okay.
And it plays a bunch of different games and can do some language and can do some things with pictures, but it does all of those things worse than a human. But it's the first time that a model has done many different things at once to a reasonable degree. The real benefit of AI is teaching it one specific thing and getting it really good at that one thing. And that's obviously not the same as humans, at least not normal humans.
Yes.
You could, yeah. So we want to use it to make our jobs easier, and we do very specific things. So doing one part of our job is really a useful application for it. And yeah, this data-driven aspect, right? So your data is going to Netflix when you click on movies, it knows what movies you're interested in. So that data is being used to show the AI what else you might be interested in, right? That's how they do that. And that's the same thing for advertisers. They show you things they think you might be interested in from your data. Without the data, the AI is useless. And I think that's sort of the key message from me, at least. And the future limitation and the future dream, it's all data driven. So yeah.
Very nice. Hongming, you agree?
So Micah actually did a great job in explaining what it is. Only one thing I would comment is something I learned after I came to Tsinghua, Beijing, because they somehow really fancy by the concept of physics-inspired machine learning. So two things in here. One is they want to examine physics laws using machine learning. And the second is they want to use machine learning to rediscover some physics law that we used to know, say the Kepler's laws. So with these, like scientists use machine learning not only to do things that we have to do, but before we doing actual science, but actually directly use machine learning for scientific discoveries or relationship interpretation. So that's another thing. For the limitation, I really agree. I fully agree. And to be honest, the use of AI is largely limited by how developers think and how they decide to use it. At the moment, global AI is, too far from us. So it's really depends on how we use it and what motivates us to use AI in different scenarios.
I see. That's very interesting what you say, the part where they link physics to AI, because this is what we want to do, right? We want to do science. We don't only want to see at pretty images of galaxies and, say, oh, this galaxy is a spiral, this galaxy has depth, this galaxy is bent. We care about why this galaxy is spiral, why this galaxy has jets, right? Why this galaxy is bent. So there's, that is the motivation, at least for the scientists. We don't want to sell you, a product. We want to understand the universe, but we do use similar techniques, right? So my understanding from how AI works is that we apply similar techniques, for example, in image recognition, as you would do for, identifying a car from a bicycle, right? Something like that. Yes, but it's all about the data. I like this approach, how you phrased it. So I think it's more understandable now from everyone. You give us a few examples about classification in astronomy and, how you can use it in physics. Do you want to be a bit more specific? What can we do with AI when it comes to astronomy?
I'll let Hongming start this one.
Okay. Okay. So let me give you a example. Say, so when I was a master's student, I was given a job to identify all really big on the sky. You can easily see it on the sky, that those big radio galaxies. on the whole southern hemisphere. So I was given the job to make a radio galaxy survey by eye. So what I did back in the year was I sit in front of the computer, 2 big screens, with my master's supervisor, Dr. Patty Leahy, 6 hours to 8 hours a day. And we sit side by side, just walking through every single map.
Sorry, I've done that.
It was beauty, you know. That I like watching I like looking at the galaxy images. They look really beauty, and there are many morphology and, you know, the different physical process behind them, and you know. But these process actually took 12 months, and you know, that was really a pretty much work, right? And to be honest, back then the amount of object we need to eyeballing was about 5% to or even just 1% to what we are facing at the moment. And that took me a year, and my supervisors a year. So we were always thinking, can machine learning, can any algorithm perform these kind of object hunting and classification we could do as a human automatically with really high validity level and reliable. So that's what triggered my PhD project, do all this kind of research, and motivate me to now, is that we want to finish this job without human.
And within our lifetime, also.
Yeah, that would be ideal.
Yeah, that'd be really nice.
That'd be ideal. Yeah. So so that's part of my motivation, to be honest. And that's my scenario of applying machine learning.
Very nice. So you were the example that Micah was describing before, this optimal PhD student with a coffee and 120 galaxies per minute. My God.
That was me.
Wow.
Except I forgot it's also the supervisor that has to do it at the same time. So it's even more of an issue.
Because the problem is the error rate.
Yes, you need someone to, and not only one, you need someone else to verify, agree or disagree, because we are humans, we have some preference, and what we know as a background story of what that object, for example, the physics, or if we don't know the physics, will influence how we look at something. And also humans have this ability to look at the cloud in the sky and imagine it as an elephant. And the same thing happens when we look at galaxies in the universe. So,
and people get tired. Computers don't get tired.
Yeah.
They don't make, even if they're wrong, they're consistently wrong. Which is almost more useful sometimes.
Very nice. Yes. So Micah, tell us your opinion on this.
Yeah, I think
some specific examples.
I think classifying radio galaxies is a really important one. I mean, it's severely biased because that's what I work on. I was at a conference, I think last week or the week before, and a lot of different people were talking about all these different ideas, and just a few examples of where AI is being applied in astronomy. One person is using it to, or two people tried two different approaches to process data from very large instruments without all of the complicated and very computationally expensive, so it takes a very long time to do the math on a computer. They tried to skip all that by just applying AI. And it worked incredibly well, surprisingly well, actually. Convincing astronomers to use it might be a different battle, but that's one place that I sort of didn't expect to see it, but it is showing its face. Other places where it's in active use include things like finding rare and unique sources that sort of are abnormal. If something is very abnormal, it'll look different to the computer. It doesn't warn you about that, but you can go and check in its sort of brain as it's processing. And another thing is you can find sort of any signal that that changes. So I know that there's applications in astronomy to solar flares, right? Understanding when solar flares happen is going to be really important because surprisingly, we're all shocked by using the internet here that our universe and our understanding of how humanity works right now is based on digital infrastructure. And if a massive solar flare comes, we need to know ideally before it hits Earth, which is possible, but it's very tricky. And so getting that information very quickly and reliably is very important. So there's applications everywhere from what we do, which is extragalactic sort of, what does this galaxy look like, to, you know, will the sun explode just a little bit too much for us to handle? And I think that's pretty cool.
Very nice. Yeah, it's definitely important to know about solar flares. Definitely, it affects telecommunications. I mean, we might not be able to do something about it. It would be not.
So I think the approach would be to turn everything off.
Yeah.
So there was a solar flare, I believe, in the 1800s, that if it happened again today, it would cause trillions of dollars worth of damage to our infrastructures if everything was on. But if we can turn off the safeties between power systems and like I would unplug my computer at home and things like this. But you separate the power system from the actual cables and hope that everything survives enough. I think that's the approach.
So we can still have internet to discuss about science after that.
Yes. A week later, maybe.
A week, maybe. And we don't go back to the 1800s.
Exactly.
Very nice. So we have a very wide application, right? Very wide applications in astronomy, and it's pretty much used in, or will be used in every part of the data life cycle as we understand it now, because this is the new era of astronomy in all the fields, not only radio, large data. So it's, okay, I don't want to talk, it's petabytes of data per day, and for some radio telescopes, and it's going to be per hour as, you know, radio telescopes grow and develop, like the square kilometer array and all these things that we are preparing for. And now we're trying to do it with small samples and small surveys in the sky where, you know, okay, you have these little parts in the sky and you want to identify all the sources in there and classify them. But imagine doing this in the whole sky and every hour, because this is the future of radio astronomy, at least. So it's an amazing tool. But people think it's a bit scary, no? Like they think AI will steal our jobs. They took our jobs. What do you say about that? Will it steal our jobs?
I can go first. I may be a little bit, there's a wide variety of opinions. And what we see historically from other industrial revolutions, which is essentially what this is to a large extent, is that jobs have been lost and other jobs have been created. And in healthy economies, the economic impact of these revolutions have provided support for those who lose their jobs. So that's sort of what the worst case scenario, that's what should be happening if your government isn't horrible. And on the other side, I think I would like my job to be stolen by AI. Like Hongming said, right? Like we don't want to sit there in front of a computer for 12 hours a day for a whole year to find, you know, 100 new objects and then have to do it again for a different type of object, right? That's not what we want to do and not what we want to spend our time on. So yeah, hopefully in good ways, it'll steal our jobs.
Yeah. Hongming?
Just following Micah. I guess that our job as scientists perhaps would not be that much affected because these kind of repetitive work is about some fraction of, it's only one part of our daily research work. And even if they're all automated, we can still have many scientific ideas. We do our job. We do research, we publish papers, whatever. And in So for those loose jobs, we can see that the creative business and those providing services are now booming. At least here in China, it's true. The content economic is boosting in every area. So I wouldn't be that pessimistic, but yeah, I believe that when people lose jobs, they will have new jobs that fit their requirements.
Okay.
Except you need to use different package of ability.
Yeah, so a bit of retraining might be necessary, but this is also true for scientists. We learn something new every day. We don't stay static. We have new skills. We attend new seminars and schools. So we always try to advance. And I think this advances society also, right? Society should also advance and not stay static in the 1800s, for example.
And just to set people's minds at ease, I realize that we're sounding maybe, depending on what your job is, maybe we're scaring you a little bit. Keep in mind, machine learning and AI work best for very specific applications. And sort of the thing people go to, at least in conversations I've had with people, is automation of industry, right? Building cars, right? You have these massive factories now with a lot of automation. But if I'm entirely honest, most of that isn't machine learning. Machine learning isn't amazing at controlling robots yet. We're still a number of years away before that happens. And I think the closest I've seen to AI actually taking someone's job is journalism, which is, I think, really funny.
I'm sorry. I'm sorry to my friends, journalists. But
yeah, so it's also not the same, right? So the AI will do a certain thing and hit a certain tone. But keep in mind that each of us knows one thing, right? Usually, like, we're very good at one thing, right? I'm not a tennis player. I'm not, a world-class anything else. I'm very good at the one thing I do, and I'm sure you're good at something too. And it's really hard to teach AI to do anything very well, let alone the thing that you do very well. So for journalists, being able to control the pace of an article or the amount of information you're conveying or how biased that is, that's all very important. And all things that AI is very bad at controlling right now. So I'd say we're still a number of years away for most people for any sort of disruption to their industry.
Very interesting. I have two things about what you said. Amazing. Okay, right. So one thing about what Hongming said and one thing about what you said, the bias in the data, right? So we have AI also, not only in journalism, and I'm sorry for the joke before, it's also relevant to my question, the next question. But before that, because, for example, now companies use AI to look through CVs of people if they want to hire someone for a specific job. But so I have a friend of mine who works trying to make this data sample for training the AI not biased. Because if you put a biased sample in, then you will get a biased answer. So if your sample is only, I don't know, you want to hire a CEO for your company, and if your sample is only white male, you will hire a white male at the end because the AI will dismiss all the other CVs. So what they're trying to do as data scientists is to provide an unbiased enough sample so the AI can be trained, the algorithm can be trained properly and be more fair, to the selection, and also get the best candidate, because maybe they will dismiss the candidate because of the other criteria, not the skills, right? So that's very important, and we're not there yet because we don't have the sample. That's the most important thing. And the other thing I wanted to say, so I will play the devil's advocate here. Right. So Hongming was saying about we're writing papers, AI cannot do that. And I imagine the world where AI, because has access to the database of all papers, to the archive where we have access, but we don't know it, can potentially write a very, very good article that has all the references needed, you know, historical references, current references, some future approaches based on what people think, and write a better scientific paper than us faster. So wouldn't this be bad for us that are scientists? And this is what we are proud of, that, you know, we can combine the knowledge and get to the point where we can explain science. So will this be a thing to worry about?
At the moment, I'm not worried about that.
Yep.
I mean, when that comes true, I guess it will, we will not be too far from global AI, if that's actually happening. Yeah. So I wouldn't say in the next few decades it would happen.
Our generation is safe.
Yeah, maybe.
We are safe. It's okay.
Yeah.
No, it's just no, but it can also be used as a tool, in the sense that I see this now, and it saddens me also when I referee papers, because there's such a huge amount of publications now, and we also have a little gap. We don't know maybe all the literature from the last century that they had very important discoveries, but maybe because the papers were not cited as much as current papers, they were not known. So what happens is that somehow we are reinventing the wheel. And I've seen this in many radio astronomy papers, where they discuss about, oh, we discovered this new population of objects, but no, that's not new. These people have been discussing about it in the 70s and 80s and 90s, but we didn't have the telescopes to discover this huge amount of objects, for example, right? So there is a little gap in our knowledge, and it has to do with the huge amount of information that we have to intake. So maybe AI could be a very useful tool in that sense, to provide to us with all the relevant references, so we have a more thorough understanding of the topic, you know, and not base it on papers where they cite only a few number of papers, because, you know, because of preference, because of bias, I don't know, because they didn't know, I mean, because they didn't have time. I'm guilty of that, you know. It's very difficult to know all the literature.
Yeah, I think it's, I would probably argue it's impossible. There's a lot of literature, you know your supervisor's literature, you know yours, and you know sort of the people that they cite and you cite and that those people cite maybe, but there's this nth degree issue where someone somewhere would have only cited people before them, and you just won't find them. As far as, I think, research applications of AI, there was a really interesting application where I think DeepMind worked with mathematics researchers, and they developed a model that pointed the maths research in the right direction. And it was reported in the media as, oh, AI discovers math, right? And that's like a really great headline. Journalism, well done, good job, people. But as far as like actual information goes, so the AI, they taught it things that they thought might be interesting, things that they knew weren't solved, and used very, very clever AI engineers and AI researchers to develop sort of a way of finding what the AI thinks is interesting. And by looking at that, they were able to sort of like build a bridge as human researchers, knowing what they knew and saying, actually, well, no, this is interesting. Like, we should have looked here before. It's been missed, or no one thought of it, or no one actually pursued it to the same depth. And I think that's sort of what we should be expecting, is sort of this augmentation of our research, right? So finding these rare objects, or looking at new physics, or looking at new models of physics might all be possible with sort of this augmented full data view of our astrophysics.
Very nice. Very nice. Okay, I will take you now to the last topic of this discussion, which is what do we do with all this data? I mean, Hongming classified for a year, right? But in the world, there are more people that can help us. So we call this citizen science, right? So tell me a few things about citizen science and how we can use it for, the benefit of science.
Okay. So yeah, let me start it. So citizen science is, I would say, a broad topic in the last couple of decades. Have some of us knew Einstein at home. We knew SETI at home. That was, I wouldn't say last generation, but it was popular. And still many astronomers are using data outcome from these projects nowadays for their research. So these generations of citizen science, we call, I don't know how I can call it, but basically citizen scientists in these generation, they provide a computing power. So the computation power to scientists of typical projects. Back in the day that the professional scientists, they don't have as much computation power they need. So they arrange these large global computer network around the world to help us or help them to make discoveries, to do those computation work. And that was a big platform, Ionic, if I was right, back then. And there was also in astronomy that perhaps we have a network of amateur astronomers who are interested in discovering new objects, say exoplanet, say supernova. So they have their own, perhaps small telescope, but they are separated around the world and organized by some professional astronomers. They're actually one of my pre-colleagues here in Tsinghua did this job. And so basically they have, they scheduled interested objects around the world. So these amateur astronomers, they observe the same object at different timing in a year. And with all the data combined, they made new discoveries of exoplanets. So that's what they do. That's another type of citizen science. And the third type that I knew is what we do. It's called data-driven citizen science, is that we project astronomers build a platform as a user interface. And we provide the data that we want to do data mining, but we don't have that many experts in our team. We do classification, we detect objects, we count the numbers of rare animals, we identified artifacts from gravitational wave detection, we do research on psychology and history of any kind of social science. So that's what we do. So there was a interface, as I mentioned, in between is the platform. So the one we work on is called Zooniverse. One side is we scientists as professionals, and the other side are the general public who are interested. We call citizen scientists. So that's, but anyway, we work together and we discuss and we move forward the boundary of knowledge. And that's what I think about citizen science.
Micah, any thoughts? And how AI can be used with citizen science? Maybe adding a question.
I fully agree with Hongming. I don't know as much as Hongming does about citizen science. For me, I think it's a great opportunity for people to engage in really like wild and frontier level astronomy in our case, but there are other fields. So the platform we use is called Zooniverse. You can Google it, it's a thing. And
Zooniverse.org.
Zooniverse.org, yeah, plug. Yeah, I think AI can be used in really interesting ways there. So we want to use it in two ways in our projects, one of which I'm more familiar with, but the two basic concepts are We want to be able to provide not just whatever data the user gets is what they get. We don't want to just randomly give them pictures. In an ideal world, we want to give them sort of the most interesting pictures, right? We don't want to waste your time as a citizen scientist on looking at the same thing that just looks like a boring old thing, right? Ideally, that's not what we do. That will happen as well, but ideally that's not what we do. So sort of ranking and finding which ones we want to show you in priority and get more information on the more interesting objects, that obviously helps the science as well. It's a win-win, and that's something you can use AI for, or methods related to it. The other thing we want to do and we're working on is developing plain English that still does the science. And that's something that we're using AI for, to actually find what English we can use that still does the science, that you understand, that we understand, that there's no educational limit where we're like, no, you need to actually do these 10 training courses before you can actually be useful. And in an ideal world, anyone who speaks English could pop on and work with those terms. Yeah, and I think so citizen science is sort of the baseline we need. Like we said before, we need the data to do AI. We don't just hire PhD students for that. So it's best to have data sets from citizen scientists and using AI to augment their experience to make it better and smoother, as well as improving the science. That's all like just a beautiful synergy that we can make use of.
Yes, very nice. And before we go to tell them what is our project, because we also have a fantastic project that is almost there. It's going to be on Zooniverse very, very soon. We're sorry, I'm so excited. We're working very hard to get it online. Before we go there, we'll play a game. Okay, and now it's your chance, Micah, to shine. This time, okay. I'm joking. Okay, both of you will sign because you know the answers. It's very easy. Okay, I swear. It's true or false. Maybe it's not so easy.
Exciting.
Okay. Yeah. So okay, it's okay. So the first question of true or false is: the term artificial intelligence was coined in 1955 by John McCarthy, professor at Stanford University. True or false?
I'm going to go with true.
And you, Hongming, you can both play. You can go up or down for true or false. Yes, very nice. Well done. Yes, it's true. So apparently he wrote a proposal for a conference where he used this term, and then it sort of, took momentum from that. Very nice. 1955. So second question. Scientists want to develop artificial intelligence because they are lazy.
True.
True. Okay. I wrote these questions late last night. I was in a very funny mood. Okay. Because we're also funny people who will say it's true, but it's false. We're not lazy. We're just interested in the science. We just don't want
efficiency.
Efficiency.
Efficiency that we're looking for.
We are being German about it.
Yeah.
Okay. Third question. SETI at Home Citizen Science Project started in the International Year of Physics 2005.
Can you say that again? Sorry.
SETI at Home started in 2005.
I'm going to copy Hongming's answer.
Say that again.
I'm going to copy Hongming's answer.
You're going to. Okay.
I believe in you, Hongming.
I actually don't remember it. How can I say it?
I think it's false.
Yes. It was Einstein at Home, I think. This is also one of the quiz questions. So if you watch this video, you will have one question right. Okay. Yes. Because SETI at Home was in 1999, if I remember correctly. And now it's stopped, but they are still processing the data to find, extraterrestrial intelligence and, maybe ET. Maybe. Right. The fourth one. There are over 90 citizen science projects in Zooniverse.
I think that's true.
How many?
90.
Over 90. Over 90. Mm-hmm.
Yeah.
So they're about everything, right? They're about birds, waves, brain, teeth, I don't know, classifying, trying to find things,
I've seen some on like murder mystery, Sherlock Holmes, the sort of things.
Oh, wow.
Yeah.
Okay.
Yeah.
Maybe I
Like
should.
documents from Scotland Yard, I think they're using documents from that.
Oh, no, right.
This is all sorts of stuff. Yeah.
Okay, that's interesting. So not only astronomy things, but every discipline, and you can help scientists do their science. So have a look and keep an eye for our project. We will reveal the name in a little bit after this final question. So there are thousands of citizen science projects in the world. True or false?
I'm going to go true because I think I can argue it.
Depends on how you define one.
Yeah.
But you said we have 3 definitions, so.
Yeah, and okay, let me think. I would say over 1,000. Yes.
Over 1,000. Okay. So because I have no idea, I Googled it. So Wikipedia has a page about this, and they quote over 3,000 citizen science projects, and there is a database. It's called SciStarter, where they document citizen science projects, and in the Wikipedia there's a table where they also give the discipline. So there's a bunch of astronomy ones, but I don't think they list all 3,000. I didn't look through them, but yeah, this is what they quote. So it's very interesting, and thank you very much to the general public for helping with science. Good, guys, you were excellent. Well done. I told you you will do very well. Okay, so now we will reveal. I should have like a drum roll here. The name of our citizen science project, because this is the best citizen science project you will ever do in your life. Ever.
No, there's no aliens in ours, but it's still better.
It is the best because, okay, look at the people that are running it. Okay, we're awesome and very funny, and we're not lazy. Okay, so our project is a direct spin-off from the Radio Galaxy Zoo, where they classified radio galaxies. So our project is called Radio Galaxy Zoo, Evolutionary Map of the Universe. So it's a big word. So the small one is RGZ-EMU, and you will find it soon at zooniverse.org. And this is an advertisement. Okay, so we're building this platform. Hongming is building this platform, and we will be doing tests, and we will be launching very soon. So we hope you can sign up and identify and classify radio galaxies, and you can help us with science and to train, algorithms so we can classify millions of galaxies. And also what Micah is doing, provide easy words from the English language to describe this object. So this is something new, and we're very excited about this. So we hope you can join. And I want to ask you, Hongming and Micah, so we talked about artificial intelligence, we talked about science, we talked about the society and the people that really like doing these projects. So my question is, how do these projects benefit the society? So what do we give back? Because we just don't do these things for our own benefit only and for the benefit of science. We always want to give something back to the society. So what do we give back?
Should I go first?
Sure.
Okay. So I cannot. I don't like to make too vague promise. So I will only mention one project. It's called. So as Anthony said, our project is called the RGZ-EMU, right? So we have a subgroup at the moment called RGZ EMU EDU. So that's one aspect we are going to provide back to the society. These side project is education stuff. And we, at the moment, concentrate on high school children, not children, teenagers, sorry, my bad. High school, and we also focus on undergrad level education in the future. So the project basically will teach both astronomy and machine learning basics to high school level students. And ideally, we hope we could help these participating students and also the attending faculties to know not only the knowledge, but how we think, how we face this uncertain time as scientists, and also provide them some service about, the career planning, because they are facing with this before they enter universities, right? And one highlight thing about this, because we really cared about reducing inequality. So I'm now doing a survey with my local network to reduce gender equality. Okay, to reduce gender inequality, because from my knowledge, we need to make connection with more, the minority students in local schools. So we are actually now doing this kind of surveys locally. So perhaps we could reach out to them in the next couple of months, and try to benefit them, and perhaps pave the way for them for higher education.
Very nice. Very exciting. Very exciting. Micah?
I just want to slip back into my role of big general statements.
Yes, very nice. We like them.
To strike a balance here. So I think we haven't really spoken about it that much, but why we even classify these things is sort of the long-term science impact of this project. One, we can't do what we want to do without citizen scientists. So there's our science does not exist without that. So that's one side. What's the purpose of our science and what does that benefit society is a great question. And something a lot of people struggle to justify, right? It's not like our incomes, everything that we have comes from the public, from public foundations or from private donors. And but the scientific impact to the world is something that always is under question. In our case, classifying galaxies helps people understand the mechanics and the physical processes which lead to the galaxies looking different, being different, behaving differently and abnormally. And that extra physical understanding trickles down into textbooks. I mean, this is like not a new thing. General relativity is a very famous example of this, right? It was discovered in 1912. And without it, we wouldn't be able to make corrections to GPS. And so we wouldn't have GPS, right? Like that's a foundational example that I think is a really good one. It's taken, 90, 100 years. But in the end, all of society has benefited from that significantly. And obviously science can be used in negative ways as well, but there are ethics boards and ethics committees these days that sort of encourage that not to happen. And yeah, so I think the scientific impact isn't going to be felt for a long time, but when it is felt, it will be foundational and societal shifts that we're providing to humanity as a whole.
Yes, no, it's very important what you said, because there are so many applications of science or things that scientists created in order to do their science, like the Wi-Fi that was invented in Australia and CSIRO. And now we cannot live without Wi-Fi, even when we go for coffee. So, you wouldn't have Wi-Fi if it weren't for astronomers in Australia, right? Or as you said, the GPS and general relativity and the VLBI network that is linked to that, because you measure hydrogen masers, like atomic clocks, very, very precise timing that is needed for GPS. So these are linked to science. You don't see it now instantly. When we do the science, you will see it down the line for sure. And it's very important for scientists to do fundamental science, because in order for us to be able, for example, to classify billions of galaxies, we need to create tools, that these tools eventually are going to be used to make your life easier in automating a procedure that would take, I don't know, days or months, and it can be done in seconds. Because all these algorithms that we write can be applicable to something else. It doesn't mean that you can only apply it to classify an object. So that's the magic of, let's say, fundamental science, and this is why it should be funded. Even though the idea seems out of this world, like a scientist wants to look at the sky with a big telescope, why? Then it all goes back to the society. The society advances, the educational aspect of the society advances. People, we don't stay stuck in time. We evolve with the science. We learn new techniques. Our brains get bigger, and we like the program you said, Hongming, is very important to bring this to the classroom, right? To do this bridge, to link it to basic education, because there is some disconnect between what happens at a high-level university to the schools. Because of this, it's very natural. The advancement of science is quite rapid, so it will take some time to go back to education. So our role as a scientist is very important to bridge that gap faster, so we don't lose generations. And then we have, we can have literate people, highly educated people throughout all ranks of society. So this is very important. Yeah. Yes. And our project is going to do all that because it's awesome.
Just to bind this back to AI a little bit. So the AI tools that are used in astronomy are a little bit different they behave differently to how they do in industrial applications like Google photo search and things like this. And one place where they're quite similar to, because of the nature of the images, is healthcare. And so medical AI is a really big thing, and something that's essentially not going to be used to replace doctors. Again, we're not about replacing things, not for another 50 years at least, but about augmenting their experience, right? If a doctor has to look through fewer pictures because the AI is confident of certain ones, or can pre-annotate images of cancer and things like this, then the doctor has less work to do, and it saves them time and provides society with a better healthcare system. So that's sort of the most immediate effect I can think of our direct work, at least.
Yeah, no, that's very important. Astronomy does link to science, also MRI and all these imaging techniques. So they come directly from astronomy. So it's very important. Astronomy is not dissociated from the rest of the world. So we're here to bridge the gap. Good. This brings me to my last question to you, unless you have anything else to say about artificial intelligence or citizen science? No? Okay, so I always ask this at the end of a discussion with a scientist, because I like this question. It makes you wonder a bit. What do you think will be the next big discovery? Because we are astronomers, so we always want to bring it back to astronomy. Hongming? Okay, Micah.
I'm not that.
I think in astronomy, the next big thing will be understanding the processes through which. So obviously, very biased view here, but I think as a scientific community, we're fairly close to understanding how and when and why radio jets form.
Mhm.
And I think that's something that's a really open question and can only be studied in space, right? We don't get these we can't build a laboratory to test this. It's too big. And so I think with the data that we're collecting, I think there's a real chance that we can actually push that boundary and understand why and how these things form. And I think that would be really interesting. And I think that would make a lot of astronomers very happy.
Yeah, me too. Hongming?
So I came with one, I wouldn't say it's a big discovery, but it would be really good to find out was how merged galaxies interact within the environment.
Okay.
When I say the interaction is not only the visible part, but the invisible part, say the dark energy and dark matter. How those this is something I learned recently, how those dark matter halo interact with each other. And what do they look if they are visible somehow? It would be great if we could have more knowledge about them, and then we have one step forward about understanding of not only galaxy evolution, not only galaxy formation, but the nature of dark energy. That's something I would like to know.
Yes, you and the rest of the world. Yes, it's a big mystery, right? I mean, the only thing we can say in the universe is visible matter, and that's 5%. Let's remind our audience. And the rest of the matter in the universe, the 95% we cannot see. And then dark energy, this is the biggest percentage of our universe, like 2/3. We don't have a clue how to observe it. I mean, there are some surveys now that are trying to observe it. For example, it's DES, right? They're trying to count how galaxies inside the cluster move and try to measure it. But these are very difficult experiments also for dark matter. We haven't directly measured it. We have seen the effects, as you say, in clusters. A very famous one is like this bullet cluster, where one cluster goes through another and they leave back this X-ray shape, like a bullet, thermal emission. But yeah, I think it's fascinating. It's a fascinating era for astronomy. And we hope we get more funding to do these amazing discoveries for sure.
I just want to point out that I was very restrained on what do you think is going to be the next big discovery, and Hongming went straight to finding out what dark matter is. So our roles of generalist versus specific has switched for that last question for sure. I really enjoyed that.
Yes. To keep the balance always. It's very
always.
Nice.
Always are.
It's good. It's good. Excellent. Well, this was the last discussion for this season 2 of Astronomy on Tap Jena. Hongming and Micah, thank you very much for joining. I had a really good time discussing with you and playing the games, and I hope you guys at home enjoyed it too.
Well, thank you for having us, and thank you for those at home.
I'm sorry for the difficult taboo. It was a bit mean. I apologize. Just to say that I would never get any of them. I'm really bad at this game. I'm the worst, really, really. So maybe you feel better this way. And yeah, guys, we renew our date for season 3. Hopefully it will happen from September onwards if everything is well. So take care. Follow us on the social media, okay, for Astronomy on Tap Jena. And of course, in a few months, go to zooniverse.org and look for our project, RGZMU, and sign up to help us with identifying and classifying objects. Good. Thank you very much, and see you soon.
Thank you, everyone.
Thank you, Elmi. Bye. Thanks, Micah.